that.
Okay, go ahead.
All right. Hi, I'm Matthew Lehner. I'm a PI of the Taos 2 project. I work at Academia Sinica in Taipei at the Institute of Astronomy and Astrophysics. Well, we ran Taos 1 for a number of years in Taiwan. It was a kind of a low-budget project with some small 50-centimeter telescopes. It was successful in that it exceeded its design specifications, but we didn't find any of the events we were looking for. It turns out that the solar system didn't cooperate with our project. So we realized we had to do a much more deeper and wider survey in order to find the objects we're looking for. So we talked over with the director of our institute, and he said he wanted to do this. So he told us, go figure out how to do it and we'll get the money for it. And we said, okay. So our design goal is to do about a factor of 100 improvement in sensitivity relative to Taos 1. So we needed bigger, better telescopes, we needed a much better sight, and we needed better cameras as well. Oh, there's a number of them. The hardest part is that the events we're looking for are very short in duration, about 200 milliseconds long. So we need very high speed readout. Normally, when you do astronomy, you're looking at something very faint and very far away. So you might take an exposure for 30 minutes or so with your camera. We need to take exposures at 50 milliseconds with our camera. And not only that, we need to have a wide field. So we need to cover about 2.5 square degrees in order to look at our nominal target of 10,000 stars at a time. And astronomical cameras are not designed to read out at this high rate of speed. So we had to use special custom imagers in our cameras. The other challenge was just working, Taiwan versus Mexico. It's very international collaboration, but a lot of the work is happening in Mexico, but a lot of the funding and manpower is in Taiwan. So I end up doing the brunt of the work. So and also, a lot of times people have one telescope. We have 3 telescopes we have to operate and maintain and install, which is, as you can see, we're in the process of doing that now. And these telescopes need to work synchronously. All 3 telescopes will be looking at the same stars at the same time at the exact same 20 hertz readout rate. Very good. Originally, we planned to put this in Hawaii. We have a base, our institute in Taiwan has a base of operations in Hawaii because they're a big part of the sub-millimeter array, which is like sort of a microwave telescope array up on Mauna Kea. So we have an office there and we're set up for that. We'd been working for 2 years to get the permits to go there. And then when they decided they wanted to move the 30-meter telescope to Mauna Kea, they told us to leave because they didn't want to have two telescope proposals at the same. We were small potatoes compared to that. So we had to look around a lot. We looked at a number of sites, and in the end it was going to come down to either San Pedro Martir or CTIO in Chile. And I should probably turn this off. One of the main things is that CTIO was, 48 hours from Taipei as opposed to 24 for San Pedro Martir. It's you got to go through Los Angeles to get to Santiago from Taipei. It's a brutal flight, but also the people here at UNAM wanted to collaborate with us, whereas CTIO, they just say, give us money and you can come here. So we've actually had a lot of support from the local crew here that we would not have had in Chile. And that would have been, much more difficult given the distance to Taipei. So in all, it's been a good experience. The local SPM office here has done a lot of work. They did a lot of work with the roads and the electrical installation and getting the foundations built and hiring and managing all the contractors to do the construction on the site here. So it's been a great collaboration, I think, and in my view. I'm really happy we ended up here and not in Chile. When we had we were trying to make the decision, I was pushing hard for this, so I'm glad people agreed with me, because there was also a push to go to Chile. So. Well, that's a good question. We really have no idea, because nobody knows what's out there. There are certain hints that the distribution of Jupiter family comets, we believe those come from the edge of the Kuiper Belt. And we can look at the size distribution of those, and there are a lot of dynamical models which predict, the size distribution required out at the edge of the solar system to give rise to this class of comets. But these are just model predictions, but none of the things we're looking for have actually been observed out where we're looking for them. So there's also the New Horizons mission, which recently flew by Pluto, measured the size distribution of the craters on Pluto and Charon. And so that also allows us to make a prediction on what we might see. So, but it's, the models are not very precise, and there's a lot of wiggle room. So, we might see a few events, we might see a couple hundred events. It really depends on what's out there. And we also really, we have a good idea of what the performance of the system is going to be, but we need to measure that once we have it up and running as well. So that will also play a key factor. Yeah, okay, yeah, so this is not quite a telescope yet because it doesn't have any optics. This is mostly just the optical support system. As there was downstairs, you saw the mirror cell, but that is the big primary mirror will bolt on the bottom here. And then this thing over here, this ring, will sit up on the top of that, and that has a secondary mirror. So light will come down, bounce up to the secondary, back down through the center hole, and then there'll be a camera down here. And then this mount can move around north, south, and east and west and track the sky. So we've got most of the structure in place now. There's a couple little things we need to wrap up on the electronic installation. And we think sometime next week we're going to be ready to start installing the optics on the telescopes. Well, the first light is really going to be dependent on the delivery of our cameras. The telescopes should be looking at the sky in some limited capacity with test cameras by the end of October. As to when we're going to start the science survey, we need to get the custom science cameras made. Those are being made in Taiwan right now. They're a little bit behind schedule, so the last I heard is they're thinking maybe March for delivery. So that'll give us ample time to run these telescopes with test cameras, work out all the bugs in the system, so when the science cameras are ready, hopefully we can just bolt them on and at least the telescopes are going to work. Well, I need to know how these things work. I need to know how they go together. Somebody needs to know how it all happens. And also, I just want to help and get things going. Also, politically, the contract for the installation is with the telescope company. It's between the telescope company and my institute in Taiwan. So if they have problems or if they need things, they need to be able to talk to someone, the person running the contract, which is me, and then I need to deal with it. So I think it's a lot more, things run more smoothly if I'm here for that. So also it's kind of fun.
Well, thank you very much, Matt.
Sure.
You are very busy here. Thank you for your time.
That's fine. I don't mind taking a break from work.
Thank you.
All right. Is that it?